All right, so today we're looking at polynomials, and this is lecture 13. Of course, my name is Hamted, and then we're going to start with the factor theorem. We go to the remainder theorem, and then we finish with the polynomial inequalities. Yeah, so first you need to know what a polynomial is. So the word poly comes from, the word polynomial comes from the word poly, or it's made up with the word poly and nomial. Poly simply means many, and then nomial in this case it's going to mean term. So in other words, we're trying to talk about a function with a lot of terms or many terms. Yeah. So polynomial can have constants, variables, and exponents. Yeah. So an example of a polynomial is this one here. Oh, this n here, I just forgot. Okay, these two n's you are seeing here are supposed to be the powers. So this is read as ax to the power n plus bx to the power n, n minus 1. Yes, let me just write it here. So a polynomial p of x, I don't know why it has just changed, because this is not how I wrote it. It's supposed to look like this: x to the power n, and then plus bx raised to power n minus 1, then plus, it goes on up to a constant. The numbers keeps on reducing. All right. So now let us try to look at the factor theorem. So when you talk about the factor theorem, it's just the way in which you can factorize any given polynomial. So when factorizing a given polynomial, which has the degree greater than 2, you need to use trial error method. So in other words, when finding the first factor of a given polynomial, you have to use the trial error method. There may be other methods, but here we're going to stick on trial error. Yeah, I will show you the simplest way of using this method. So for example, when you have been given such a question, yeah, here is the question. It's saying factorize the following polynomial completely. Okay, factorize the following polynomial completely. So that is the given polynomial there. So first of all, as I earlier on said, use what is called trial error method. And how do you apply that? So you start first by trying the numbers. You see which number, when you replace it where there is x in this expression, is going to give you 0 as the answer. So let us try to put -1. When we put -1 there, we raise -1 to the power 3. This is supposed to be in brackets. Then we say minus 2x. Oh, sorry, not 2x, but 2. -1 to the power 3. Sorry, this one is to the power 2. And then minus 5. While there's x, we put -1. And then plus 6. So this is -1. -1 to the power 3 gives -1. -1 to the power 2 is +1 times -2. You get your -2 like that. Then -1 times -5, you get +5, then plus 6. So here what we're doing is we're trying our x. Say try x being equal to -1. So when you add this, can this give you 0? Because this is -3, and then this is 11. -3 plus 11, you get, is it 8? Yeah, you get +8. It's not giving you 0. So meaning -1 has refused. So let us now try x being equal to positive 1. So what of now x is equal to positive 1, if x is just equal to positive 1? So if x is just equal to positive 1, we're simply going to erase the negatives there. And then let us see what we have. So if x is equal to positive 1, this is going to give us 1, this is going to give us negative 2, and then this is going to give us negative 5, this is going to give us positive 6, to remain like that. So when you add the two, negative 1 and positive 1 and negative 2, you get negative 1. When you add negative 5 and positive 6, you get positive 1. So when you add negative 1 and 1, you get a 0. So meaning x is equal to 1 as accepted. So what you do is you take this 1 to the other side where there's x. So you're going to have something like this: x minus 1 is equal to 0. So how do you now get the factor out of this? The way you get the factor out of this, you just say x minus 1, you put it in brackets, and you say x minus 1 is a factor. You can write it using your pen. So x minus 1 is a factor. So we have found one factor which can go into, we have found one factor which can go into x cubed minus 2x squared minus 5x. So now it's now our duty to find the other two factors. So on this question, I'm going to use two methods. So the other way we can find the other factors that can go into this expression is by dividing this x minus 1 into x cubed minus 2x squared minus 5x plus 6. So when we divide this factor into this expression, this given expression, we're going to get the other remaining two factors. So so we can do that. Let me just write our first factor here. So I'm going to use two methods. So our first factor here is x minus 1. So now we're looking for another factor, which is q of x is a function on its own. So when you multiply these two, you get back to that. So now let us try to find this qx. How do you find it? So first of all, I think let me use first long division. After long division, I'll also show you how to use synthetic division, which is the simplest. So when you're using long division, you get this x minus 1, you put it there. Then you get this expression, you put it inside there. So this will be x cubed minus 2x squared minus 5x plus 6. So now we start dividing x into x cubed, you get x squared. X squared times x here, you get x cubed. X squared times negative 1, you get negative x squared. And then here what you do is you subtract. So we subtract x cubed minus x cubed, you get 0. Negative 2x squared minus negative x, you get a negative x squared. Then you divide this x into negative x squared there, you get negative x. Then negative x times that, you get negative x squared there. Of course, you bring down this 5, this negative 5x, you put it there. Then this x times negative 1, you get negative x. Again, you subtract. This will give you 0. And then negative 5x minus negative x, you get negative is it negative? What is this? How the question is? This is negative 5x, then minus x. Let me just try to check the question. Oh, sorry, when you multiply this negative x times 1, you get a positive x there. So meaning when you add the 2, you are getting negative 6x. All right, it's now correct. Just made a mistake on multiplying. Yeah, so, and then what you do is you again divide this x into negative 6x, you get negative 6 there. And then you do what? And then you proceed now by multiplying this negative 6 with, let me just bring down this positive 6 first. So negative 6 times x, you get negative 6x. Negative 6 times negative 1, you get positive 6. So when you subtract these two, you discover to say you are getting zeros down there. So now, if you have a number here, this number is the one that we call the remainder. Now, if you have the remainder which is equal to 0, it means that what you have found on top there is also a factor. So this qx here is this quotient that we have found there, which is x squared minus x minus 6. This is the quotient. So here we all know how to factorize the quadratic equation we learned in the previous lectures that we had. If you have forgotten, you can check in I think lecture, yeah, you can check in the previous lectures that we've been having on quadratic equations. So when you factorize this, you are going to have something like this, minus 1. And then when you factorize this quadratic equation, you get your factors as you have x plus 2 as one of your factors. Then you also have x minus 3 as one of your factors as well. So when you do this, means that you have factorized the polynomial completely. Yeah. Now I said I'm also going to show you how to use synthetic division. So synthetic division, you just draw a simple box like this, and then you put this, where is our factor? Oh, the factor was x minus 1. So we had our factor being x minus 1. So this was initially equated to 0. So our x is equal to 0. This is how it, oh sorry, not 0. It's equal to 1. So our x is equal to 1. This is how it was. So you put your 1 there. Then you get the coefficients of what is in this given polynomial there. So we have the first coefficient is 1, the second coefficient is negative 2, the third coefficient is negative 5, the last coefficient is 6. Yeah, and then what you do again is you bring down this 1, you bring it down there, you write 1, and then you multiply this 1 times 1, you get 1. You add, so you have brought it down this 1, then you add negative 2 plus 1, you get negative 1. You multiply this 1 times negative 1, you put it there, negative 1. You add negative 5 plus negative 1, you get negative 6. You multiply this 1 times negative 6, you get negative 6. When you add 6 plus negative 6, you get a 0. So these numbers that you've got here are the coefficients of your quotient. So in short, our q of x that we have found here, you write, the first coefficient we have is 1, so I will not write it, I'll just write x squared. The second coefficient is negative 1, so I'll write negative x squared. And then the constant there is negative 6. You can see that this quotient that we have found here is just the same as this here on top. So what we were using here was synthetic division, and then what is being used here is long division. Sorry, long division. Yeah. So we proceed. So this is how you factorize completely. This polynomial has been factorized completely here. Let us now look at other questions. We look at the remainder theorem. Remember what I said on the previous question. If you have a number here, it means that that is the remainder. If you have a number here, if you're using long division, it means that that is the remainder. Now, how do you now know to say a given factor is living, a given expression when divided into a polynomial, is either given it's either giving a remainder or not. How do you know? How do you tell whether it's giving a remainder or not? So let us try to look at this example here. The question is saying find the remainder when the polynomial p of x is equal to x cubed plus x squared minus 12x plus 20 is divided by x minus 2. So what the question here is saying is, when we divide x minus 2, when we divide this x minus 2 into this question, what remainder are we going to have? What remainder are we going to have? So such questions are very simple and straightforward. What you do is you don't stress, you don't use long division, you don't use synthetic division. Yeah, if you want, you can use them, but you just waste your time using those methods. So the simplest way you can find the remainder when you divide this given expression into this polynomial there, when the easiest way you can find the remainder is just by finding p over this given expression here. So this given expression is x minus 2. So you just equate this to 0, and then you say x is equal to, when you take this 2 to the other side of the equal sign, you get x being equal to 2. So meaning, while there is x in this expression, we're going to be replacing with 2. So we're going to say we're finding p of 2 is equal to, where there is x, I'm going to put 2 there, then plus, again, where there's another x there, I'll put 2. Of course, here when you're writing such questions, don't forget to put brackets. They're very important, just in case the number there is negative. And then minus 12, while there's x, we put another 2, and then plus 20. So when you simplify this, this will give you 8, this will give you 4, and then this will give you negative 24, and then plus 20. So just by looking here, you can tell to say this is 12 minus 24, you get negative 12 plus 20, you get, I think that should be a negative 8. Is it? Sorry, it will be a positive 8. You get positive 8 because this, yeah, you get positive 8. Yeah, so we proceed. This is how simple such questions are. This is how simple such questions are. You don't have to stress when answering them. When you've been told to find the remainder, when you divide a certain given expression into a certain polynomial, you just have to equate first that given expression to 0, and then make x the subject, and then let the number which you are going to find here, which is going to be on your right hand side of the equal sign, replace it in the polynomial, and then find the answer there. So this is the remainder, meaning whether you use synthetic division, you use long division, you still get this same 8 as the remainder. All right, let's look at the next question. So our next question is saying, using the remainder theorem, write the function in the form px is equal to, px is equal to x minus k, q of x plus r, where q of x is the quotient and r is the remainder. So this is the question we've been told, and we've been given to say the value of k in this expression is equal to 2. So in other words, what they are trying to say is this P of X, this P of X is equal to 1. While this K, we've been told to say we can put 2 there. So in short, in other words, this X minus 2 is just the what? This X minus 2 is a factor. Yeah, is a factor. They are saying using the remainder theorem, right? A function. Yeah, no, it's not really a factor, but it's just something that when we multiply it with Q of X, it's going to give us the remainder R. So this Q of X is a function as well. It's just a function. Yeah, just a function which is a quotient according to the equation. Yeah, so plus, and then R we've been told to say is the remainder. So how do you deal with such equation? So here now you can use synthetic division or long division, and let me just use synthetic division because of time, because at least synthetic division is a little bit simple compared to, it's not that complicated. It's not, you cannot easily make a mistake. So synthetic division, sorry, this is how you go about with it. So we've been given to say x is equal to, sorry, x minus 2. We equate this to 0, and then you say x is equal to 2. So what we're going to put here is 2, and then we put the coefficients of this given polynomial there. So we have 1, we have another 1, we have negative 12, and then we have 20. So what you do is you bring down the 1 there. So when you multiply 2 times 2 there, oh sorry, this is 1, not 2. Bring down the 1. So when you multiply 2 times 1, you get 2. When you add 1 plus 2, you get 3. Multiply 2 times 3, you get 6. When you add negative 12 plus 6, you get negative 6. When you multiply 2 times negative 6, you get negative 12. When you add 20 plus negative 12, you get 8. If you can remember, and if you have observed, this expression is just the same as that expression. This factor here, I mean, this expression is just the same as this expression there, which is here. This is the reason why we've gotten the same remainder, which is 8. So the number that is here is always called the remainder. Yeah, so this is the remainder. Now let us write our Q of X. So our Q of X, our quotient in other ways, is just equal to, so our quotient is equal to X. So the coefficient of X squared is 1. The coefficient of X there is positive 3. And then our constant is negative 6. The last number here is the remainder. So if we were to write it in this expression, according to the question, we can write it now to say P of X, yeah, P of X is equal to X minus 2, and then our Q of X is X squared plus, yeah, sorry, this is a plus 3x minus 6. You write it like that, and then you say plus. Our remainder is 8. hence expressed or hence written. Yeah, we've written what they wanted. So this is the final answer. So these questions are simple and straightforward. I don't know why you just complicate things when you look at a question, you think everything is now hell. Yeah, this is how you solve such questions. They are very simple. So we proceed. So let us now try to look at the polynomial inequalities. Once we look at this, we'll just do maybe 2 or 3 questions, 2 or 3 examples on the polynomials, then we are done with polynomials. The next time we meet, we begin logarithms and exponentials. So the question is saying factorize the polynomial x cubed minus 3x squared minus 4x plus 12. Hence calculate the range of values of x for which x cubed minus 3x squared is greater than 4x minus 12. All right. So we begin. So first of all, they are saying factorize this expression. We need to factorize this. And remember what I said on the factor theorem. When you are factorizing a polynomial, first of all, or the first thing that should come in your mind is using trial error method to find the first factor. So when you try there, let us try to say we take x. Yeah, we take x, we try x being equal to 1. So when you try x being equal to 1, you put 1 there, you get 1 minus 3, you get negative 2 minus 4, you get negative 6 plus 12 gives you 6. It's not giving you 1. So that one is not accepting. Let us try 2. You can try negative 1, you can try 0, or not 0, sorry. You can first try 1, negative 1. If they fail, you go to 2. If it fails, you go to negative 2. So let us now try to say let x be equal to positive 2. Let's try to put 2 there. So when you put 2, when we put 2 where there's x, 2, so it's going to be 2 cubed minus 3. We put 2 there, squared minus 4x. Also, where this x we're putting 2, plus 12. So this is going to give us 8 minus, this is 4 times 3. 4 times 3, you get 12. And then this one is giving you 8. This one is giving you positive 12. You can see that this 12, this positive 12 and this negative 12 are cancelling. So applies to this negative 8 and that, this positive 8 and that negative 8. So in other words, when you add those, you are getting a 0. C is 12. We're getting a 0. So when you get a 0, just know to say x is equal to 2 is part of the zeros. Yeah, in other words, these are called zeros. They are called zeros. Okay, let me just do this question quickly because time has started counting down. We're just remaining with 10 minutes. So 2 has accepted. So meaning one of our zeros is x minus 2. So in other words, this x minus 2 is a factor. So if this x minus 2 is a factor, we've been told to factorize it completely. And then we find this range of values of x. So if x minus 2 is a factor, we need to divide it back into this expression to find the other 2 factors. So let us use synthetic division. So x is equal to 2, we put our 2 there. Then we put the coefficients of this polynomial there. 1, we have negative 3, we have negative 4, then we have 12. And then we bring down this positive 1. So 2 times 1, you get 2. When you add negative 3 times, plus 2, you get negative 1. 2 times negative 1, you get negative 2. When you add these 2, you get negative 6. 2 times negative 6, you get negative 12. When you add the 2, you get a 0. We have the remainder 0 there, which shows us to say x minus 2 is a factor. So now we find the other factor. So we're going to have x minus 2. And then this one will be, the first coefficient there will be 1. The second coefficient will be negative 1. And then the constant there will be 6. So due to time, I'm not going to solve this, but I'll just give you the factors. So the factors are going to be x plus 2. Yeah, we have x plus 2. And x minus 3. So when you factorize this using either completing the square method or using factorization method, you get these factors. So now these, we've been told to say there's a greater than symbol here, meaning there's, when you take this 4x minus 12 to the other side of the O sign to look like this, and then to be a greater than 0 somewhere like this. So in other words, just like this. Yes. So first of all, we find the critical points by equating all these three factors to 0. So when we equate x minus 2 to 0, you find your x to be equal to 2. When you equate x plus 2 to 0, you find your x being equal to negative 2. When you equate x minus 3 to 0, you find your x being equal to positive 3. So now, since we're finding the ranges here, it means that we have to draw the number line. We have to find the range of values of x. So we put our negative 2 there, we put our 2 there, and we put our 3 there. So we know to say all these numbers that are this side are less than negative 2. And then the numbers between here are between negative 2 and positive 2. The numbers between here are 2 and we have 3. And then the numbers this side are greater than 3. So we can try to test these numbers here. Numbers less than 2, when we put them here, you discover that when you put negative 3, for instance, here, it will get a negative answer. When you put negative 3 there, you get a negative answer. When you put negative 3 there, you get a negative answer. Then when you multiply everything there, you still come back to the negative. Now, is a negative number greater than 0? It's not. So this part cancelled. We move on to the next part. The next part here, when we take a number between negative 2 and 2, we can even get 0. 0, we put 0 where there's x there, you get a negative answer, because 0 minus 2 is negative 2, which is a negative answer. When you put a 0 there where there's x, you get a positive answer. 0 plus 2 is still a positive 2. When you put 0 where there's x there, you get a negative answer to be 0 minus 3. Yeah, when you multiply the 2, you get a positive answer. So is positive greater than 0? Yes. So this part has accepted. We move on to this part again. You get any number between these. You get 2.1 minus 2, you've got a positive answer. 2.1 plus 2, you get a positive answer. Now try to put 2.1 here and say minus 3, you get a negative answer. When you multiply everything there, you get negative. Is negative greater than 0? No. So we move on to the last part. Get any bigger number, which is bigger than 3 there. We can get 4. 4 minus 2, you get a positive answer. Yeah, 4 plus 2, you get a positive answer. And then 4 minus 3, you get a positive answer. So the final, when you multiply positive, 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 you get positive. Is positive greater than 0? Yes, so even that one accepts. So now how you conclude is you say therefore the value of x is equal to, if you want you can write them in set builder notation, but I like it when it's in interval notation. So it's going to be negative 2 comma 2, like that. Then you say union, this would be 3 comma infinity. So this is how, so this is how you conclude. So that is basically the final answer for this question. Let us now move on to the next question. The next question, which is the last question we're going to do, is saying given that x minus 1 is equal to, and x plus 3 are the factors of px cubed plus qx squared minus 3x plus 7. Find the values of p and q. So here what you do, we've been told to say x minus 1 is a factor. So meaning we equate this to 0. This is 0, not 6. So x is equal to positive 1. At least we found one value of x. So what you do is you replace it in this polynomial. While there is x, you put positive 1. So when you put positive 1 where there is x cubed there, you get p, and then you put 1 there cubed, and then you say plus q, you put 1 there squared, minus 3, you put 1 plus 7. So they are saying these two expressions are what? Are factors of this. And a factor is a number that goes into another number without leaving a remainder. So in other words, I'm trying to say, when you replace 1 where there is x there, you get your final answer to be 0. So in other words, we're trying to say p plus q. When you add these, you get positive 4 being equal to 0. So meaning we have this p plus q being equal to negative 4. So this is your first equation. And then you find your second equation by replacing x. You say x plus 1, time is even up, is equal to 1. So meaning, is equal to 0. So meaning x is equal to negative 1. So you replace where there's x in this expression, you get something like, so you get your answer like this. It's going to be p minus q. It's going to be, let me just do this, although time is up. But there's an exercise at the end, so you're going to answer this exercise and submit. P minus q is equal to 10. So you solve these two equations simultaneously, and then when you solve them, you find the values of p and q. So when you solve them, you discover that your p is going to be equal to 3, and q is